some other students to join. So we're starting off with the quiz for those of you watching on YouTube, which I assume will be a lot, judging by attendance today. But yeah, let's just get started. First question. You want to require that derived classes implement a method without providing functionality for it. Which OOP concept can achieve this? This quiz is pretty tough, I think. Because we've seen a lot of the questions from object-oriented programming already. So the only ones left are fairly tough, I think. This one's maybe not too bad though, just by like the definition of the word, I guess. So yeah, without providing functionality, it's almost like saying something is, okay, 50-50. So yeah, abstraction is the correct answer here. Remember, encapsulation is about security. So if it was something like you want to determine where specific properties or methods are accessible, then the answer would be encapsulation. But yeah, abstraction is correct here, so nicely done. Next. Which keyword is used to declare a class that does not provide an implementation for one of its methods? So which keyword would we use to declare a class that doesn't provide a body for one of its methods, doesn't provide behavior for one of its methods? Which word would we use? Sorry if there's some background noise, by the way. Ooh, 2 people said static. Okay, this one was actually related to the previous ones. So remember in the previous question we asked, which concept can help us create methods that don't provide functionality? And here we just replaced the word functionality with implementation. Okay, so this question was actually related to the previous one. So yeah, the correct answer is abstract. Static is when if you declare any property or method as static, that means it belongs to the class. That means it belongs to the class, okay? So each one still gets its own copy, but it means you don't need an object to access it. Okay. Which type do we use to reference a method when working with events? So which type would I use to create a reference to like a method? Or how else can I put this? Which type would hold a reference to a method? Okay, 50-50 again. So string is a bit of a trick here. Okay, string will hold any like a bunch of characters. Delegate is correct. I'm surprised neither of you went for ref, which is cool because ref does stand for reference, which I thought was a little bit tricky. But yeah, delegate is a type that references a method. Okay, nicely done. Yeah. Which statement would you use to add the upload method to the clicked invocation list defined by an event? So I want to add the upload. Upload is the name of the method, and I want to add it to an event called clicked, obviously without removing anything else that was added. So how would we do this? I want to add the upload method to a list defined by the clicked method. I mean the clicked event, sorry, the clicked event. I did draw your attention to this last week, or at least tried to. And yeah, this is it's an important idea. So you're given the name of this invocation list defined by an event or a delegate. and you want to add the upload method to that list. How would we do it? How did we do it at the end of last week's? Okay, let's see what people said. Ooh, okay, interesting. So the correct answer was to say clicked plus equals upload. I switched them around to show you that the fact that upload was on the left was because uploaded last week, uploaded was the event list. This time you're told that the invocation list is clicked. So when you click a button, the clicked event is called and the upload method must run. Okay, or the clicked event is raised. So you must add it to the clicked invocation list. So we're adding to the thing that is on the left. So the invocation list must be on the left and the method that you are adding to it must be on the right. And it's always plus equals. Okay, always plus equals. Okay, on to the last question. You want to be able to share common functionality between the classes you have created. Which OOP concept can achieve this? So you want to be able to share functionality between different classes. This one's not too bad, I don't think. Share common functionality. Oh, you guys answered quick. Nice, cool. Both of you got that one. That's awesome. Nicely done, guys. Cool. This one was a tough one because we're sort of running out of we're running out of questions in chapter 2. Wow, Chris, you wrecked it. Nicely done. But yeah, that was a tough one, and these things are mostly for revision, guys. So don't worry too much about it. Okay. Oh, cool. I see some other people have joined us. That's cool. Welcome, Chico. Welcome, Abongwe. And yeah, let's just get started. I expected attendance to be a bit bad today, just given that, you know, some scheduling issues due to load shedding, but it's all good. Today's lecture should actually be, I think the content is quite interesting. We're going to be creating a sort of text-based adventure game because today we are learning about interfaces, okay? So interfaces are very commonly used in developing games, okay? Like in Unity, interfaces are very common for that kind of game development. We're going to be it's going to be super simple, okay? Like nothing too complicated, but it'll get the idea across of what an interface is. Okay, before we start with that, I do just want to remind you guys about abstract methods. Hopefully the quiz refreshed your memory a little bit, but we're going to go, I'm going to actually just show you to remind you what abstract means, okay? So how we describe abstract, how we define abstract. So one easy way to remember it is just what the word abstract means in English, okay? It's the opposite of concrete. Okay, so it's defining an idea, a thought, so existing in thought or as an idea, but not having a physical or concrete existence. Okay, that's what abstract means in English. And the word abstract in C# means the exact same thing. Okay, it's the exact same thing. So if we say something like abstract public or abstract class, I'm going to create an abstract class called, actually we can keep it abstract as well. We can keep our example abstract. I'm going to create an abstract class called base. Okay, so this is my base class. Because I declared it as abstract, I'm allowed to make its members abstract. And all that means, so I'm gonna show you what it would look like if it was not abstract. So I'm gonna create a method that just prints something out. Okay, so let's say public void output. I'll call it output, okay, because it outputs to the screen. That's all this method does. Now, usually when I define a method, it'll look something like this. Okay, so this is what our method would look like from base. Okay, so look, we've got public void output, and that looks pretty normal for what we know as a method. And then we have these curly brackets, and the curly brackets are defining the functionality, the behavior, the body. We call it the body. Everything in between those two curly brackets is what we call the body of the method. Okay? So that's defining the behavior of the method. If I make the method abstract, all that means, literally all it means, is that this method does not have a concrete implementation. It is not concrete. So what that'll mean is I can just remove the body. And that's my method. Now, why would you ever do this? Basically, all this abstract method is doing is saying anything that inherits from base, any class that is derived from base, any class that inherits from base must provide a method called output. Okay, it must provide a method called output, and it must provide the full functionality for it. So what is this doing? It's saying base is just defining an idea, okay, just a thought. It's like, this is a class that outputs something, but I don't know what it outputs. I don't know exactly how it outputs it yet. And only later, when I create a proper class, when I say something like public class derived inherits from base, then I'll say something like public override void output. Okay, and then only here will I say console.writeLine and provide the full body. Okay, so what abstract is allowing us to do is define an idea. Okay, just define the idea of a method without defining. So what I've defined here is that output will return void and it takes in nothing. That's what I've defined about output here. And anything that inherits from base will have to provide a method that looks like that. Okay, so it allows you to define an idea. Now, the reason we're revising this is because interfaces kind of extend this concept a little bit. Oh, right, yeah, sorry about that. We have to make it public abstract class base. And there we go. So, cool. The idea here is hopefully you guys get it. So abstract is just defining an abstract idea. It doesn't have functionality. It doesn't have an implementation. Now, if you notice, when you look at my abstract class, I have to type public abstract and public abstract, right? You see that? I had to type public abstract, which is a bit annoying. I also had to type public class derived, which is fine. I mean, ideally you would just want to write class derived. That would be a little bit faster. And the other thing is that when you're providing the implementation for the output method, you have to type override. Because you see, if I don't type override here, if I just say public void output, you as a human can probably see that when I say public void output, my intention is to provide an implementation for that output method that is defined as abstract there, right? But when I run this, C# doesn't understand this. It goes derived does not implement inherited abstract member base.output. So what all that's saying is we do not provide an implementation for the output method. You have to say override to make it clear that you're overriding that abstract method, okay? Now so it's forcing me to type a lot extra. And interfaces kind of solve this problem for us. It makes it a little bit easier for us to define this idea. Okay, so all interfaces are classes. So when you're asked a question about classes, you must answer as if interfaces do not exist. Okay, when the MTA uses the term class, it is not referring to interfaces at all. Okay, but a good way to think about interfaces is that they are classes where everything is public and abstract. Okay, they are essentially classes where everything is public and abstract. Okay, so moving on from there, maybe that sort of analogy didn't do it for you, but we are going to see a proper interface example for what you might use this for. Okay, so we're going to do a full interfaces example. So yeah, interfaces are similar to classes, but everything is abstract. Okay, everything. And a good way to think about this, I think, is in creating a game, because that'll show you why we actually use this. So currently you've seen this idea of polygon, polygon being this abstract idea, and rectangle and square being concrete examples of polygons. But maybe that's not related enough to actual real world programming problems for you to get it. And so what we're going to do today is create quite a realistic example of where this might be used in like video game development, for example, or even in other places as well. You'll see the goal here is for you to see the utility, see the benefit of using interfaces. Okay. So I think a good way to think about this is if you were making a game, right, you might have like a lot of weapons, for example. So let's say you're making a game where there are guns, okay? Like a shooter game, a first-person shooter. It could also be like a fantasy genre game, all right? There'll be a whole lot of weapons in your game. And each weapon might be slightly different, right? Like bows are slightly different to swords, and swords are slightly different to spears and things like that. Like they have different ranges, different amounts of damage, different ways to attack things, right? There's lots of ways that different weapons might be different. But you'll also notice that there are some common traits, right? Like all of the weapons would be able to attack enemies. All of the weapons will have a amount of damage. All of them will have a range, some range. Whatever their range happens to be isn't really relevant to us. What matters is that they each will have a range. Okay? And you can see already that this could be solved quite well with inheritance. But interfaces make it even easier to define this kind of idea because you don't have to type public abstract everywhere. You can just write interface and everything else is handled for you. You no longer have to type override. It'll just be assumed that you're overriding if you're inheriting from an interface. Okay, so that's what we'll see now. So for example, we might have a weapon like a spear. So spear will implement the weapon interface. And by the way, when we're naming interfaces, so if you want to interface for weapons, you would call it IWeapon. If you were creating an interface for websites, it would be iWebsite. If you're creating an interface for enemies, it would be iEnemy. Okay, that's how we name interfaces usually. They're also often named as like verbs. So instead of saying weapon, you might call it attack or something like that, okay? And instead of calling it an enemy, you might call it an attackable, right? Because then both buildings and enemies could be attackable or something like that. But just keeping it at this level is perfectly fine, and you can understand it at this level, okay? You might have another weapon called a boomerang, right? And boomerang will also implement the weapon interface, okay? And this is how we can do this already, right? You guys know how to define that structure on the left. It looks very similar to when we had person and doctor inherited from person and nurse inherited from person, right? Likewise, we can define an I-enemy interface where we have zombies who are I-enemies and we have cowboys who are I-enemies, okay? Now, currently, if we were doing this with inheritance, it could be slightly more difficult to handle because things might not necessarily be abstract, right? So for example, if I want to be able to use my spear to attack zombies, okay? I want to be able to attack zombies with my spear, okay? If we were going to create that, we would have to add an attack method to spear, right? And likewise, if I wanted my spear to be able to attack the cowboys afterwards, or my boomerang to be able to attack the zombies, I would have to create an attack method inside boomerang to attack zombies. And I'd have to create an attack method inside spear to attack cowboys, and an attack method inside boomerang to attack cowboys. So you can see that was 4 different, right? We had boomerangs attacking cowboys, spears attacking cowboys, boomerangs attacking zombies, spears attacking zombies. There's a whole lot of complexity going on there. Instead of defining all of that, what interfaces will allow us to do is to just say, oh, all I weapons, every single I weapon will be able to attack I enemies. Okay. So instead of defining those 4 relationships where I say spear attacks zombie, spear attacks cowboy, boomerang attacks zombie, boomerang attacks cowboy, we'll be able to say all weapons, so spears and boomerangs, will be able to attack all enemies, zombies and cowboys. Okay. And so when there's only 4 like this, you might go, oh, I guess that's slightly more convenient. I'm now defining 1 relationship instead of 4 relationships. And so you go, okay, that's slightly more convenient. But actually, it's even more than that, because you can picture if I was adding another, let's say I added another weapon. Okay, I added another weapon. Do you have a question, Abongwe? Feel free to type it in the chat or to speak through your mic. It's cool. So,
hi.
Hello.
Hello.
Hello, hello. I hear you.
My question is, so if you were to like use GTA as an example, would you type steal, I steal? For like, if you wanted to like steal a car, maybe if you wanted to make your person steal a car or something.
Yeah, exactly. So you might define a stealable property or hijackable, and you'll have like a whole lot of different vehicles, right? Like you might have planes, or sorry about if there's any background noise there. So you might have planes, boats, and cars, and all of them will be hijackable, for example. And anything marked by the hijackable interface will be hijackable, okay? And likewise for enemy, in our case, in our example here, we have enemy, and anything that inherits from enemy or implements. So when we're talking about interfaces, we don't say inherits, we say implements. So anything that implements the enemy interface will be able to be attacked, okay? And anything that implements the weapon interface will be able to attack. And likewise in GTA, you could think like any vehicle that implements hijackable will be hijackable, and any character that implements hijack would be able to hijack hijackable things. Okay, and that is like this would be the proper way. This would be how they do it. Okay, in any AAA game, any game, you'll use interfaces to implement these kinds of things because it keeps it way simpler than it usually would be. So you can picture how fewer relationships. But yeah, good example. And it's good for you to be connecting these things into your head with examples that you're familiar with. But you can picture the convenience of this is if I added another weapon, right? Like let's say, so we had spears and boomerangs, and I now add another weapon like gun, okay? Instead of having to say, oh, gun can attack zombie and gun can attack cowboy, I don't have to change anything. Gun will already be able to attack everything that's an enemy. Okay? And likewise, if I add a new enemy, I don't have to go and modify spear and boomerang. Whatever enemy I add will already be attackable by spears and boomerangs. I won't have to change anything. And that's the power of interfaces. So what we're going to see now is how this works in code. But the basic idea that we'll be defining in code now, but understand that this is general, right? Like you can use interfaces for a lot of things other than this. But what we're going to be using these interfaces for, just to show you guys the idea, is that the weapon interface is going to say, if you implement weapon, so if you implement the weapon interface, you must provide a way to attack enemies. Okay? And that's the relationship we're going to define. But interfaces can be used for even more complicated things as well, if you wanted to. Okay. Anyway, let me remove this example. So that was just linking it back to something we have learned already. And guys, if you're saying, wow, this looks very similar to abstract, you're correct. It is very similar to an abstract class. An interface is very similar to an abstract class. But if you're being asked about classes, you must be thinking about abstraction and abstract classes. If you're being asked about general structures, then you must be thinking about interfaces. Okay. So just be careful of that. But if you are thinking in your head, like, this is reminding me a lot of abstract classes, that's good because they are very similar. They're doing very similar things. It's just interfaces are slightly easier to like type out and think about. Okay. So it's just that it's, again, one of those things where programmers are very lazy. Okay. If they can save typing anything, they will. Anyway. So I think let's just start by defining the basic structure. The first thing, we're going to start by defining enemies. Okay, because obviously, so the weapon interface will state that if you implement weapon, you must provide a way to attack an enemy. The first step of this like recipe here is creating I enemies, right? Because if we don't have I enemies, our I weapons won't have anything to attack. So we're going to create I enemies. On the slide here, I have zombies and cowboys. I think it's more fun if you guys recommend some enemies. Okay. Do any of you have any ideas? What enemies should we add? Zombies and cowboys are cool, but do you have any other plans? Dragons, goblins? What do you guys think? Anyone wants a particular enemy that they want represented here? Ghouls. Okay, Yusuf suggests ghouls. I like that one. That's a creative one. We'll go for ghouls. And Chris says golem. Okay, yeah, I like both of those, the creative ones. So yeah, we're going to implement, on the slide, it's zombie and cowboy. And cool, you could add those yourselves afterwards. I will share all of the code with you guys once the lecture's done. But for now, yeah, we're going to go with ghouls and golems. Okay, ghouls and golems. Okay, but before we create ghouls and golems, what we need is the I enemy interface. Okay, the I enemy interface. So all I have to do to create an interface, it's very simple. You can see if I type interface here in like a C# editor, you can see it highlights interface in purple. You see interface is highlighted in purple. We know what that means, right? Anything that's highlighted in purple, that means C# knows that word. C# knows that word. So C# knows the word interface. It's a keyword inside C#. And then I'm just going to say I enemy. And we always name our interfaces. We put I in front of them. Like that's even like where the names iPhones and stuff come from is from these kinds of standards. Okay. Anyway, so the I enemy interface. So we've gone ahead and defined that. And there we go. We've defined an interface. Super easy. Now you can imagine if we were creating like a proper game, our enemies might have a lot of different traits, right? Like all of our enemies might have an integer defining their hit points, for example, int hit points, right? And you guys can imagine the other things that an interface would probably have. There would be many different things that an interface could create. I should just point out where we are in the book, by the way. So their interfaces are on like page 56. Okay, page 56 is where it starts, understanding interfaces. We're going to go a little bit more into detail than what they do in the book, because I think it's like quite an interesting thing, really. Okay, so you can define a whole lot of different things, and you can imagine that in an actual game, I enemies would have a lot of traits, right? Like they would have a number of hit points, the amounts of damage they do to you. Maybe they would have a level. They would have, you know, lots of things, lots and lots of things. We're going to keep ours simple. We're going to say our enemies have a certain amount of hit points. Okay, I think that one's not too bad for us to do. And we're going to say all of our enemies have a certain damage output. Okay? We're going to keep our game pretty simple. Okay, all of our enemies will have a certain number of hit points and a certain amount of damage. Okay, all of them, every single I enemy object. The other thing that all of our I enemies are going to be able to do is attack you. Okay, they're going to be able to attack. So we're going to define a simple thing. We're going to say void attack. Okay, and that's it. That's the I enemy interface done. Okay, and you can picture, you can add other things easily. If you wanted each of your enemies to have a name, you could just add string name get set, right? Bam, then all of your enemies will have to provide a name. You could add a whole bunch of other things, and you can add them easily. If you wanted your enemies to be able to run, yeah, so Abongwe is asking us like another question relating it to GTA. So if every vehicle is hijackable, but you can't get into a lot of houses and buildings, would this be harder to code than hijacking because the specific places? Yeah, precisely. So like a lot of buildings you can enter into, for example. So like those buildings, marking them as hijackable, you would probably need a different way to handle the logic of stealing them, right? So yeah, that's a good way of thinking about it. Like interfaces can make it easier to define some relationships, but some things are very difficult to define still, right? You have to be very careful. Like the interesting thing here is like every single I enemy will now have hit points and damage. But you can imagine if our game contained enemies that don't do damage, either we could set their damage to 0, for example, but what about like an enemy that needs to be able to hold a weapon? How would we define that within this interface? So there are some other complexities that you would have to think about, definitely. But you'll see that interfaces do provide it's a simplification of what the problem would otherwise be. Okay, but it won't solve all of your problems. Definitely not. It won't solve everything. But yeah, cool. Hopefully that answers your question, Bongwe. Okay, so we've defined the I enemy interface, and as I said, you could add a whole bunch of other things to this. Okay, you could add a lot of other things to this, a lot of other traits that I enemies could have. Okay, but for now, we're going to work with this I enemy interface, and we're going to define now a golem. Okay, or okay, we'll define ghouls and golems, both of them, because we're going to have two enemies just to show you guys the relationships. We'll start with saying. So we'll define public class golem in implements. So we do use the colon still, and you guys have learned the colon as meaning inherits, and it is very similar. The only difference here is that we don't say inherits. Because it is inheriting from an interface and not a class, we say implements. So we're saying class golem implements I enemy. But it's essentially inheritance. You don't have to relearn anything. It's basically inheritance. That's basically what we've said here. Now, when I run this, so I've just defined golem for now. So I've said golem implements I enemy. I'm going to run it to show you what this relationship has done, what coding this has done. So I'm going to run it. It's going to give errors. Okay. So what does it tell us? It says golem, so that's the class's name, class golem, does not implement interface member hit points, does not implement interface member damage, and does not implement interface member attack. So it gave me those three errors. So already it's saying, no, you just said golem implements I enemy. That means your golem has to have a number of hit points, has to be able to do damage, and has to be able to attack. Okay, has to be able to attack. Now remember, if we were creating a class, the disadvantage of doing this in a class is we would have to say public abstract void attack, okay? And that would do a similar thing as what we just saw. You would have to define this public abstract void attack. Because it's in an interface, everything is just public and abstract, okay? The computer just reads it as that. So I didn't have to type it. Another advantage now is when I'm defining the attack method inside golem, I'm just gonna say public void attack like so. There we go. I've now implemented the attack method. Obviously, we're going to actually do something with it. But as far as C# is concerned, that's fine. So you see now it only gives me 2 errors. It says I haven't implemented damage and hit points, which we'll do now. But before we do that, I want you guys to tell me what's different about this method. I just want you to make sure you guys are concentrating. If I was doing it with abstract classes and methods, what would this method have to require still? I did just show you guys at the beginning of this. Ooh, it's quite boiling today. I think winter is ending. I'm gonna take off my jacket, I think. But can you guys tell me what keyword would I have to add to this method if I was trying to replace an abstract method, one that wasn't in an interface? So if we were doing this with abstract classes and methods, what word is missing from the attack method inside golem? Exactly. So Chris says override, and that's correct. Override is missing. I'm just going to take off my jacket quickly because it is boiling. Okay. Sorry about the noise. I kicked up my laptop accidentally. There we go. Oh, that's so much better. Geesh. It's good to know that summer is starting. Right? Okay, yeah. So Chris, you're correct. If we were doing it with abstract, we would have to add override. Okay, I am connecting this back to abstract because I don't want you guys to be confused, because I know a lot of you will be relating it to abstract in your head, and that's good. It's very similar to abstract. They achieve very similar goals. It's basically just that interfaces require less typing, okay? And that means that they're less sensitive to things like type, okay? They're more adaptable. All right, more adaptable. That's a good way of putting it, I think. And that's great. So the other things we'll have to define are hit points and damage, and that's super easy. We'll say public int hit points get set, and public int damage get set. Okay, and what I'm going to do is define a constructor as well. So I'm going to define a constructor as well so that we can set the hit points and the damage of when we create a new golem, like a new thing of type golem. So what I'm going to do is just say public, what will my constructor be called, guys? What is my constructor? What is the next word I'm going to type here when creating this constructor for this particular class? I do want to see if anyone remembers what's the special rule about constructors. Looking at the definition of this class, what will the constructor of this class be called, guys? Where I'll initialize all of the new values. Anyone know? Ah, cool, I see a lot of people have joined. Okay, Clark, Taffy, and Chico are here as well now. And Blessings back, cool. Yeah, I must remember to add you guys to the register. So does anyone know, what's the special rule about constructors, guys? What's the special rule about constructors? How does C# know that the method you're creating is the constructor of this class? Okay, I'll spoil it for you guys. The special rule about constructors is that they always have this. Clark, you got it in just before I start typing it, so that's cool. Yeah, so Clark says the same name as the class name, and that's exactly correct. So how C# knows that it's a constructor for the class is that it has the same name as the class, okay? And so inside this constructor, I am gonna set the hit points and the damage, okay? So how many variables is this constructor going to expect, guys? How many parameters is this golem constructor going to take in? How many parameters will the golem constructor take in? Clark, correct again. Yeah, 2. It's going to take in 2. And we can see that both of them are going to be of type int. Okay, so I'm going to say int hit points. I'm just going to say HP for short, and int damage. Okay, I'm just going to call it D for or damn or something. I can use the lowercase, but I don't want to. Okay, yeah, that's fine. Cool. Okay, there we go. And then I'm just going to say hit points with capitals equals HP. And this is the same as saying this dot hit points. You guys remember that this refers to the one inside the instance of the class. That'll come up again a bit later. And then I'm going to say damage equals damage. Okay, so that'll allow me to set the hit points and the damage for a new golem when I create one. Okay. And the last thing we want to do is we want to define some more interesting hit functionality for our golem. Okay, so we're going to say public void attack. What that void attack is going to do is it's just going to print out something. Remember, this is a text-based adventure game. And so all the golem is going to do is say golem hits you for, and then it's going to print out the damage. Okay. Now, how I did that was I put inside these curly brackets, I've just put this dot damage, and that's just going to be replaced with whatever amounts of damage this column does. Okay, it's just a special template. If you put inside console.writeLine inside the string, C# will just go ahead and replace whatever's inside the curly brackets with the variable that you put between those. Okay, so this dot damage is going to refer to this integer variable over here called damage. Okay. So let's go ahead and create an object of type golem and just make sure that this is working. And then we'll go ahead and create ghouls, and then we'll move on to creating our weapons. Okay. So I'm going to say golem. I'll call this golem1. Okay. Unless if any of you have a more interesting name for our golem, I'm happy to change it. And then I'm going to say new golem equal new golem, and I'm going to set. So golems will be like tanky, right? So they'll have a lot of hit points. I'm going to give our golem 1,000 hit points, and I'm going to give them like, let's say they do low damage. So they're going to be like 20 damage. That's going to be low in our game. We're not too concerned about balance. Okay. And then I'm going to say golem 1 dot attack. Okay, golem 1 dot attack. Going to run this. And you can see, let me just make sure what's going on here. I think we have to put a little $sign before it. No. Okay, I'll do this the other way then. Sorry about that. Oh, now I remember, I think. Is it the $sign must go here? Okay, it's been a while since I used that. Okay, cool. There we go. So you see it says golem hits you for 20 points. I should say 20 points of damage. And I guess golems don't hit, right? They crush. So golem crushes you. Crushes you for 20 points of damage. There we go. So that's a pretty good attack thing. And we should put an exclamation point at the end, right? To convey some intensity. And there we go. So let me just explain what the templating did here. So you can see the variable I put inside the curly brackets is damage, right? Like this dot damage for this column. And that was replaced with 20, okay? The thing in between those curly brackets was replaced with 20. Why was it replaced with 20? Because golem 1 has their damage set to 20. You can see if I change this to 40, it's going to say golem crushes you for 40 points of damage. Okay, so that's what that's doing. And the reason it replaced the curly brackets, the thing in between the curly brackets with the variable, is because I put a little $sign at the beginning of it. Okay, the $sign conveys that this string has a variable inside it. All right, it's just a little trick. It's hopefully it's not too confusing. If you guys want me to elaborate a little bit more on it, it's just defining a template though, basically. And yeah, don't worry about it too much. There are other ways of doing it. And you'll be programming, there'll be like a little assignments attached to this lecture. So you'll be able to get more familiar with it then. Okay. And you guys can imagine I can create more golems. So we have golem 1 here, but we could go ahead and create more golems if we wanted to. Okay. Cool. With that done, let's create a ghoul. Okay, ghouls. So it's going to be very similar. I'm going to say class ghoul implements enemy. Okay. And we're going to have to define the hit points and damage again. So I'm going to say public hit points Kaneki Ken. Okay, cool. We can name our ghoul Kaneki Ken. That's cool. We could add a name for all of them, but I'm just going to use the object name to name them. Okay. We could define like string name. And when you guys modify this yourselves, maybe you can add that. But yeah, we can think about that. And then we're going to say public damage. We need to define the damage for our ghouls as well. We're going to define a constructor for ghouls. And as you guys know by now, so the constructor will be called ghoul. It's also going to take in an integer for the hit points and an integer for the damage. And it's just going to set hit points to HP. Hit points equals HP and damage equals damage. Okay. And lastly, we have to define a way for the ghoul to attack, right? So we're going to say public void attack. And it's going to be quite simple again. We're just going to create, what do ghouls do? Do they slash? Ghouls like slash, right? So we'll say like console.writeLine ghoul slashes you for this dot damage. Okay, cool. So now we're going to go up and actually, this dot damage, I added one too many. There we go. Great. So exactly the same, basically. You can see how easy it was for me to add another enemy. And now I'm going to go up here and create a ghoul. So I'm going to say ghoul Kaneki underscore Ken equals new ghoul. Actually, we should use camel case for this. So I'm going to say Kaneki Ken like that. Actually, can we stick to first names? I'm going to call it Kaneki, so it's easier to type. And ghouls, I think, will have less hit points than golems. That makes sense to me. But they'll do more damage than golems. So like 50 hit points of damage. Okay, 50 points of damage, something like that. Again, we're not too concerned about balance. And, I said ghouled instead of ghoul. There we go, ghoul. And then I'm just going to say Kaneki.attack. Okay, so now both our golems and Kaneki attack. You can see when I run this, let me just see. I must have left out a semicolon somewhere. The dreaded semicolon being left out. Let me just find out where that is. It'll be somewhere in our new. Where did we leave out the semicolon? Public hit points. Okay, we left out the type, sorry. There we go. Hopefully that fixes most of our errors. Okay, it's still expecting a semicolon somewhere. Where did I leave out a semicolon? I can't see it. On line 19. Oh, line 19, okay. Okay, we've got more questions. I'll read out the question now. Let me just fix this one thing. Okay, obviously, there. After Kaneki.attack, I left out a semicolon. No problem. And how did I find that, guys? You see it says 19. Okay, and it says semicolon expected. So I went to line 19, and it's because this semicolon was left out. So I can put that there. So you see, guys, the errors are very helpful. Okay, the errors are very helpful. So now we've got Golem crushes you for 20 points of damage, and Ghoul slashes you for 50 points of damage. Okay, so we've now got Golems and Ghouls, and they can attack, they have hit points, and they have damage. If you were to make a text-based game, would you maybe be able to make a dice, then have every number do a specific amount of hit point damage, kind of like a board game where the dice chooses the amount of steps you can take? This is specifically, yeah, definitely, you would be able to do that. That's somewhat moving out of the context of interfaces, but yes, you definitely could. You could do random. There'll be like a system.random. We'll discuss them more on the break maybe, but like, yes, there is random number generators. So you can randomly generate a number between 1 and 6 in C# and take that as your dice roll. So yes, 100% you could do something like that, yeah. Cool. So we have created I enemies. So that's sort of like the one side. If we go back to our slide here, that's sort of like the one side of what we wanted to do. Wait, this is, the timing is pretty weird because we started at 12:45. Okay, we've still got time before we have to take a break. So we've defined the one side of this I-enemy relationship. What we want to do now is define the I-weapon side of things, okay? Because we want our weapons to be able to attack enemies, okay? We want weapons to be able to attack enemies. Does anyone have any suggestions for weapons that they want to see in our little text-based adventure game? Okay, a katana, that makes perfect sense. Yeah, I think katanas are very cool. Should we add swords rather? I don't know. I mean, a katana is a type of... Actually, no, let's stick with katana. That's more interesting, I think. Yeah, let's do katana. It's not like it's more difficult or anything, but we can maybe set the... I was thinking like maybe we could have types of swords, so you could specify the name of a sword. But no, let's just do katana. That's easier. We don't want to spend all day creating this. And any other suggestions? So we'll have katanas, but we want 2 weapons, right? So we've got katanas. So what other weapon ideas do we have, guys? There's lots of weapons in the world. Okay, let's create katanas and we'll think about the second weapon afterwards. All right, before we create katanas, we need to create the I-weapon interface because all of our weapons are going to implement the I-weapon interface, right? So what does a weapon need? All the weapon needs is damage. So it's going to have a damage output, a specific damage output, and it's going to have a specific, it's going to be able to attack. Okay, it's going to be able to attack. And now we get to our first interesting question. Okay, or I imagine we've had quite a few. Thanos's weapon. I don't know what it's called. I don't know either. So, okay, let's say, cool. Let's create the katana, and then we'll think about our second weapon. Okay. So we're gonna say void attack. Okay, but something's gonna be different here, guys. I weapons are going to be attacking something. What are they attacking, guys? What are our I weapons going to be attacking? Looking at this little diagram here. Infinity Gauntlet. Does it make sense to define a class for the Infinity Gauntlet? Surely there's only one of them. Anyway, okay, so what are I weapons going to attack, guys? Can you tell me? What will I weapons attack? Does anyone know? I enemies. Exactly. Okay. So I enemies are a type. Just like with classes, when we create a new class, we're creating our own custom type. With interfaces, we're doing the same thing. We have created a type called I enemy. And so when we say void attack, when we're passing in the parameter, we can pass in an I enemy, and I'm going to call this I enemy target. Okay. Just like you can pass integers into constructors, or you can pass strings into methods, you can pass integers into methods, you can pass doubles into methods. Just like with all of those, we can pass an I enemy target into our attack method. So what is this saying? That is it. That's our entire I weapon interface. It looks super simple, right? And that's because it is. All this I weapon interface is doing is saying that all weapons have an integer value specifying their damage, and they have an attack method that targets an I enemy, that attacks an I enemy. Okay? So they have an attack method that expects you to give it an I enemy, which it calls target. So we're just defining the structure for all I weapons having this attack method. Okay. Which is it's really useful, really powerful. So I want you guys to really appreciate what this is doing. It's defining the abstract idea of a weapon. Weapons have a damage value, and they have a method that can, like a behavior, that can attack targets. We don't know the details yet, because katanas attack slightly different from bows or shurikens or whatever. So like katanas are slightly different subtly from other weapons, but they all have a damage value, and they all have the ability to attack a particular target. Okay. So that's what the interface is defining, the abstract idea of a weapon. And now we go ahead and make it more concrete by defining a class. Okay. Cool. So that's that. We can now go ahead and create an actual weapon. So we're going to start by creating katanas. Well, remember, so the class is still just the blueprints of an object, right? So this class golem didn't create an actual golem. It created the idea of golems, but it's almost like it's making the idea more and more specific until eventually we got to a concrete object, like an actual object of type golem. When we said golem 1 equals new golem, and we specified its hit points and damage. And it's the same here. So we're now going to create a katana, which is a specific kind of I weapon. Okay. Again, we still don't have a katana object yet. So we're going to say class katana implements I weapon. Okay. Exactly like our other ones. And this just needs to define int damage. Okay. So we'll say, I'm going to say public int damage. Get set. Okay, easy peasy. We're going to define a constructor, and I'm not even going to ask you guys. Hopefully by now you know what this constructor is going to be called. It's going to be called katana, okay, because it has the same name as the class. And this constructor is going to take in one parameter called damage, and it's just going to set the katana's damage to damage. Okay, damage equals damage. We're then going to say we need to define the attack method. Okay, the attack method for the katana. So this is going to be just very similar to the attack methods of the other interfaces. It's going to be public void attack, but we now come to the first difference. This attack method takes in a target, I enemy target. Okay, like so. All right. Actually, you know what? I think it might really get the idea across a little bit better if we give our golems and ghouls names. Okay, because then you can attack a very specific target with the attack method. So, but now, guys, appreciate. So I want to make a change here. You can imagine if I defined two different classes for my enemies without defining the interface, it might be a little bit difficult to ensure that the same name parameter was added to all of those different classes. It would be a bit of a nightmare. But in order to add a name parameter to my enemy interface, it's as simple as coming here and saying string name get set. Okay, string name get set. And then obviously we just have to we still have to declare that variable inside our other classes. So this is going to be public string name get set and public string name get set inside ghoul as well. So I'm just adding a name parameter to all of our classes. And then we're just going to, instead of just, our constructor is now going to take in a name, HP, and damage. So it's going to take in a string name. String name. Okay. And our ghoul is also going to take in string name. String name. And we're just going to set the name of our enemies as well. So I'm going to set name equals name and name equals name inside the golem constructor as well. Okay, so exactly how I hit the set the HP and damage. And now when I create something of type golem, I'm going to have to specify its name. What should we call our golem? What's a good name for golem? Let's just call him Stone. That's easy. And we'll call the ghoul, we're going to call Kaneki Ken, because that was a good name for him. Cool. There we go. So our golem, so now our golem and ghouls have actual names, like actual strings specifying their names, rather than just their object names. Okay. And you'll see what that allows me to do just now. Okay. So, yes, we were underlining. Good stuff. Okay, so now inside the katana, we're going back to the katana class. We're defining this attack method. And this is the last thing. We'll take a little break after this, but it's going to be small because I do want to get through the last bit of chapter 2 like today. So our katana method, we are given a target. Okay, we are given a target. The target is of type enemy. All enemies have a specific number of hit points. They have a specific amount of damage, and they have a specific name. I can reference all of those things from this general enemy target, okay? So what you'll be able to see now is inside attack, I'm going to say, so this is the attack method for the katana, okay? So how do your katanas attack? You like slash as well, or cut? I don't know, let's say cut, or you hit. I'm just going to say hit, okay? You hit target.name with katana, with your katana for, yeah, something like that. Okay. So that's the sort of attack bit. And then obviously just for realism, okay, just to show you guys, but obviously this would be slightly more complicated for real, but this will actually work. It'll work quite well. What we're going to do is deduct the amount of damage that our katana does from the enemy's hit points. Okay, so I'm going to say target.hitpoints. And you see, C# gives me autocomplete. When I say target dot, it says, okay, all targets have an attack method. They have a damage, a certain number of damage. They have a certain amount of hit points, and they have a name. So I'm going to say target.hitpoints equals target.hitpoints minus this dot damage. So that is my katana's damage. Okay, minus this dot damage. And then I'm going to print out the amount of hit points that our target has left. Okay, we're getting super complicated. I know this is like a super detailed example. It's way more detailed than I went with some other classes, but it will help get the idea across. Okay, so then we'll say target.name has target.hitpoints. This is a very detailed example, but it's cool. It might actually be a pretty fun text-based adventure game. Target.name has target.hitpoints left, HP left. I'll say hit points left. Okay. All right. So we went super into detail there. Tell you what, I think the idea of defining the katana is probably already detailed enough. I'm not sure if we have to really add another weapon, but we might. Let's see what happens. Okay. Okay, so let's try this out. What I'm going to do now is so we've created a golem object. We've created a ghoul object. We're now going to create a katana object. Okay, so I'm going to say katana equals new katana. And I have to specify a damage value for my katana. It's strong, so I'm going to give it like 60 damage or something, okay? So, cool. So we get attacked by golem, and then we get attacked by ghoul, and then we're going to say katana dot attack, and we have to give it an enemy target. So let me show you this, actually. So when I say katana dot attack, you see it auto-completes. And inside the brackets, it says enemy target. It's saying you have to give this an enemy, okay? Golem 1 and ghoul 1 are both enemies. So let's say I want to attack Golem 1, whose name is Stone. Okay, Golem 1's name is Stone. I'm going to attack Golem 1. Okay, katana dot attack Golem 1. When I run this, so you can see, so I'm using my katana dot attack, and I'm giving it the enemy called Golem 1. Okay, so I'm going to run this, and you can see it says Golem crushes you for 20 points of damage. Ghoul slashes you for 50 points of damage. You hit Stone with your katana. Stone has 940 hit points left. Okay, so let's say I kept attacking Golem 1. So I'm going to, let's say instead of attacking him once, I'm going to attack 4 times. You can see it now says you hit Stone with your katana. Stone has 940 hit points left. You hit Stone with your katana. Stone has 880 hit points left. And it goes on until Stone gets down to 760 hit points. Okay. So we've gone and defined a pretty complex structure. And remember, so here I was attacking Stone, but I could also attack Kaneki. So I could attack Ghoul 1 instead of Golem 1. And then it'll be, you can see everything will update. The story will change, basically. So I can say you hit Kaneki Ken with your katana. Kaneki Ken has 140 hit points left. Okay. So you see the hit points changed, the name changed, and the weapon can change as well. All right. And actually, okay, just to show you guys, I will add one more weapon. Okay, just super quick. But okay, let's take a break and we'll add the weapon when we get back. Okay. We're going to take like a 5-minute break. I know it's short, guys, but I do want to get through a lot today. We want to finish chapter 4 today. Or let me post that on everyone instead. So 13:55. We'll come back. I'm just going to go grab a glass of water quickly. If you have any other questions, feel free to post them during the chat. Oh, I promised to Bongwe that we would check out like random. Usually a good way of getting through this documentation is to say system random C#. There must be yeah, so there's a system.random class, and we can see sort of how it works quickly, I suppose. But this is not officially a part of the course. But yeah, you can, there is a system.random class that you could play with, and it'll allow you to generate random numbers, okay? It'll allow you to generate random numbers, which is cool. Yeah, so it represents a pseudo-random number generator. So yeah, you can generate dice rolls, card draws, you know, anything. You can simulate anything in C#. Like these programming languages are very powerful, as I hope you guys are starting to see as we're moving on to bigger and bigger examples. I'm gonna go ahead, yeah, and grab a glass of water. If you guys have any questions, feel free to ask them, post them in the chat, and I'll get to them when I get back, okay? Yo, that was a short break. I barely made it back. I guess still a minute or so, cool. So yeah, we'll define this one last enemy. I'm gonna set up this for you guys. So the idea will be, I'm gonna give you access to this code and you're gonna edit it yourself and add your own weapon and your own enemy to the game and just play with it a little bit so that you really nail down the idea of interfaces. And really this is a good way of learning about everything, classes, everything. Yeah, this is a good way of getting down with everything, okay. Properties, because yeah, the interface, like building a game can be quite confusing because you can see this is quite a simple game and it's already, we're at 86 lines of code. Adding one more weapon, this will be 100 lines of code, guys. For like a very simple game. So you can imagine how much work goes into these like AAA games. It takes a lot of skill and dedication, I think. Anyway, so let's add one more weapon. I think I forgot how to spell shuriken, but shurikens, given like the sort of theme of our text-based adventure game, makes sense that we would add shurikens, right? So let's add a shuriken. You've seen these things before. I have thrown one before. It didn't go very well. Anyway, so we're going to say class shuriken. I'm just going to do it quickly just to show you guys one more time how we're going to add a weapon to the game. So class shuriken, what we know is going to implement the iWeapon interface, okay? Implement the iWeapon interface, like so, okay? All that means is it needs a damage value. It needs a damage value, so it's going to say public int damage, get set, and it needs a constructor, so public shuriken. Okay, and that just needs to take in one variable to set the damage value for our shuriken. And then it's going to say damage equals damage. Okay, so that's all the constructor does. And then we're going to say public void attack. Okay, and just like the katana, the public void attack method is going to have to take in enemy target. Now, guys, I'm going to stop here just for a little bit, just to show you guys how similar these two things are. Okay, look, so above the top thing, this whole thing is defining the katana. Okay, this whole thing is defining the shuriken. You can see these classes are basically identical. That's the power of interfaces. I barely have to think to add another weapon. I just needed to come up with the name shuriken. Okay, and that's the only thing that changed. Now, the only thing that will change a little bit more, that'll be a lot different, is the implementation of the attack method. It's still going to look a lot like this. Okay, so I could even just copy paste just to show you guys how similar these are. I'm going to copy paste the attack method from the katana into the attack method from for the shuriken. And all I'm going to change is that instead of saying you hit target.name with your katana, I'm going to say you throw a shuriken at target.name, and that's actually it. That's all I had to change. We've now added a shuriken to the game. And you guys can see, so I'll go up to the top. I'm going to create a shuriken object. So shuriken, shuri equals new shuriken. And I'm going to give it, let's say the shurikens don't do much damage because you know they range. And I'm just going to say, instead of saying katana.attack ghoul 1, I'm going to say shuri.attack ghoul 1. Okay. I'm going to remove the golem 1 and ghoul 1 attack. You guys know that they can attack already. But I'm just going to say shuri.attack ghoul 1. Okay. And when I run this, you can see that it says you throw a shuriken at Kaneki Ken. Kaneki Ken has 190 hit points left. If I wanted to attack Golem 1 instead, I would just say shuri.attack Golem 1. And now we'll throw our shuriken at Golem 1. So it says you throw a shuriken at Stone. Stone has 990 hit points left. If I wanted to attack the Golem with the katana instead, I could say katana.attack Golem 1. And you can see then it says you hit Stone with your katana. Stone has 940 hit points left. If I wanted to attack Ghoul 1 with the katana instead, we could say Ghoul 1.attack. Okay, I mean katana.attack Ghoul 1. Okay, so you see we've defined all of these relationships, right? And when you guys add your own weapon and your own enemy, all of those relationships will still be maintained in this very like sensible rule-based way. Okay, what I'm going to do is I'm going to add comments. So I'm going to say create objects for your enemy. Create class first. Create class first. I'm going to say create objects for your weapon. So I'm just giving you guys pointers because I'm giving you this code and you guys are going to go through and do this. And we'll go through like what sort of creative weapons and enemies you added each, like what each of you added, okay? So here's where you'll create your objects of type enemy, your objects of type weapon. And then on this line, you can say, use your weapon / enemy object. Okay, so I'm just commenting where you guys will add. Below the shuriken, or you can actually add it anywhere as long as it's inside the same namespace, but it doesn't, I'm just gonna comment so that everything stays in order. I'm gonna say, add your own weapon that implements iWeapon here. Okay, and I'm gonna say, add your own enemy, add your own enemy that implements iEnemy. Okay, cool. So when you're creating your own enemy, you compare them to the ghoul and the golem, and you just need to do something similar to that, except with your own enemy names and stuff like that, okay? And when you're creating your own weapon, you'll just look at the katana and the shuriken, and you'll add your own weapon and make sure that it's sort of similar and working, okay, and working. And then you'll be able to test that it's working. You'll have to create objects and like use those objects to attack the various enemies and just see how things work. All right. How are you going to do this? What I'm going to do is hit save here. I'm going to say, I'll call this MTA Saturday interfaces, or interface game, okay? And I'm going to hit OK. Now you can see it gave me this link. I will post this link in the WhatsApp chat after the lecture is done, so you guys will have access to it. But all that link means is now when you visit that link on Rex Tester, you guys will have to create accounts, by the way, if you don't have accounts already. Now, when you visit this link on this in Rex Tester, you'll see it'll give you all of this. Okay, it's got all the comments there, all of the green comments. You just have to, that's telling you what you have to do, and they're all in the correct place. That's where you must be doing them. Okay, so you can see there's a bunch of comments that you must work through. And how you're going to do this is okay, I'd have to access in like what you'll do is hit fork it. Okay, at the bottom here it says fork it. You're going to hit fork it. You're going to give it your own title. So say like, who was the last person who put? Yusuf was the last person who sent a message. So for Yusuf, you would say like Yusuf interfaces, okay, or interface game, something like that. You'll call it whatever you want, give it whatever title you want. You're going to hit OK. Then it's going to give you another link. So this would be Yusuf now. So you see it says at the top here, Yusuf-interface game, when you go to that link that it gives you after you hit fork it. And then you'll scroll down to the bottom. You're going to hit edit mode in the bottom right. So you're going to hit edit mode. And then you're going to be able to modify that code, okay? Where you, in your own, like your own version of it, you're going to be able to modify your own version of it. Once you've made your modifications, like you've added your weapons, you've added your enemies, everything's okay, or maybe you just want to save it and come back to work on it later. Remember, you must click Save Edits, give it the exact same name it had before, and just hit OK, okay? And then it's going to say, cool, version created, update saved, okay? And then you're done, okay? And so yeah, that's how you'll work with this example yourself, all right? So yeah, there we go. That's that. So that's the one thing I want you to do. There's a bunch of comments. I want you guys to create your own weapon and your own enemy, and then like attack enemies and all of that kind of thing. Okay. I think it's a pretty fun way to learn interfaces. Okay, and to see how powerful they are. Okay, so that's interfaces. And yeah, again, guys, sort of like an open door policy. You can feel free to contact me whenever, all right? Like literally anytime, okay? You just WhatsApp me, or you can WhatsApp on the group. Maybe one of the other students can help you as well. Obviously, I won't reply instantly all the time, but I'll definitely get to your questions, and literally it's no problem, all right? Cool. Anyway, so that's interfaces done. We now have one last thing to learn about are we going to have normal classes this year, or are we going to, I think we'll probably be online for the rest of the course. It's weird, but I don't know about this whole pandemic thing, because it'll be difficult, because some people come from like different schools, and like obviously I don't go to, so it's quite difficult to get passes and access to a class, you know. But I'm not sure. I don't know. I mean, everything is very weird this year. I don't think anyone can predict what will be happening. Okay. Cool. All right. The last thing in section 2, in chapter 2, is the IComparable interface. The IComparable interface. Okay. So we've learned now how to create our own interfaces, iWeapon, iEnemy, whatever you wanted. But now we have there are interfaces that are built into C#. Okay, there are interfaces that are built into C#. We only need to learn one of them, and that's IComparable. Okay, you can see it's named how other interfaces are named. It has the I in front of it, right? And all this interfaces does is it marks a class as comparable to another class. What do we mean comparable? We mean you will be able to find out whether that class is smaller or bigger than another object. So whether or not an object of that class is smaller or bigger than another object. Okay. So how can we give like an example of this? So we've seen that you can order numbers, right? So like if I create int x equals 6 and int y equals 7, you guys know that we can do something like x less than y, something like that, right? We can do that. We could say x equals y, x is greater than y, x is not equals to y. That would be the exclamation points. You guys have seen how we can compare these integers to one another, right? But what happens? Let's say I create, we'll keep things simple. So I'm going to create, we're going to move back to our little polygon example. Okay, so I'm going to say public class polygon. Okay, we're going to give our polygons a length and a width again. So I'm going to say public int width get set and public int length get set. Okay, I'm going to define, yeah, well, let's leave it at that for now. Actually, I suppose we should define let's define an area method. So it's going to say public int get area. Okay, and all of that is going to do is times the width by the length. Okay, we've seen exactly this before. Nothing special happening there. Okay, return width times length. Okay, so that just calculates the area of our polygon. Now, if we create a thing of type polygon, so we've seen that we can compare integers to one another. But if we can create a thing of type polygon, like polygon poly1 equals new polygon, like that, and I say polygon poly2 equals new polygon. Now, in this case, our polygon doesn't yet have a constructor, but you can imagine that we would set the length and the width of these two polygons. What do you think, what would it mean to say like poly1 greater than poly2? What would that mean? In this case, nothing, right? Like these relationships are not defined. There is no way for me to tell whether or not poly1 is greater than poly2, right? Like there are a lot of ways we could compare poly1 or poly2, right? We could say, is poly1's length greater than poly2's length? Is poly1's width greater than poly2's width? Is poly1's area greater than poly2's area? And you can imagine a lot of cases where we would want to know this, right? So for example, if we go back to where we were creating a game, let's say all of our characters or all of our enemies have levels, and we want to determine which enemy is equal in level to our character. We would want to be able to say which enemy, like we would want to be able to say like character equals enemy, something like that. Which enemy is the same as our character? Which enemy is equal to our character? But we have no way of comparing objects, right? Because the objects have so many different things about them. There's like hit points, damage, or level. In our case here with polygons, there's width, length, and area. How could we possibly determine whether an object is equal to or greater than or less than another object? Okay. And this is the problem that IComparable solves. It allows us to compare objects to one another, okay? It allows us to compare objects to one another. Okay, cool. So we have that. Hopefully that provides context for the problem that this is solving. We want to be able to compare our objects to each other. Okay. What I'm going to do is just finish defining a sort of simple example. I'm going to go ahead and define the square class again. So public class square inherits from polygon. And I'm just going to define a constructor for squares. Okay, so like we've discussed this all before. So a square is just going to have to take in a single integer. And it just sets the length and width to that integer. Okay, so length equals length and width equals width. I mean, width equals length as well, obviously, because the square has an equal length and width, okay? And we're also going to do the same for a rectangle quickly. So I'm going to say public class rectangle inherits from polygon. And we've got public rectangle. Okay, to create the constructor. The rectangle is going to have to take in a length and a width. So int length, int width, and it's just going to set the length equal to the length and the width equal to the width. Okay, so that's just a simple class relationship. By now, hopefully we've got this down, right? We've got a basic inheritance going on. Both square and rectangle will have this get area method that multiplies the width and the length. The only difference between the two is that square takes in a single parameter and sets the length and width to be equal, and rectangle takes in two parameters so that it has different lengths and widths. This is a simple example of inheritance that we've got here, and hopefully we're all fairly comfortable with this one. If you're not, then feel free to ask me and we can go ahead and discuss it in more detail, okay? But what we do now is we want to create a square and a rectangle object, so that's quite easy. I'll say square SQR equals new square. And I'm going to set the length and width to 10. Okay, so 10. There we go. And I'm going to say rectangle rect equals new rectangle. And I'm going to set this one to 1020. Okay. And the question we want to answer here is, all right, we have the square, we have the rectangle, but how do we compare them? How can they be compared? Because we've got this, we've got a couple of ideas here, right? Like we could compare the width of the square and rectangle. We could compare the length of the square and rectangle, or we could compare the area of the square and rectangle. We could also just say maybe all squares are larger or greater than rectangles, right? We can define whatever ordering we want. We could organize them by alphabetical order if we wanted to. We could literally do whatever we wanted to order these objects, right? Because there's so many different ways to order them. What I'm going to suggest is that we say all of our polygons are going to be ordered by their area. Okay? So if a square has a larger area than a rectangle, doesn't matter about its length or width. If it has a larger area than a rectangle, then it will be larger. Okay? And same for a rectangle. If a rectangle has a larger area than a square or a larger area than another rectangle, it will be larger. So we're going to compare our polygons based on their area using this get area method. All right. Now, the thing that allows us to compare these complex objects to each other is IComparable, the IComparable interface. It'll allow us to define the rules of this comparison. Before we get into the sort of technicality of how we define that, we want to just define the idea first. So what I'm going to say is polygon inherits from IComparable. We might want to do it inside square and rectangle instead, I think. No, this is fine, I think. Let's do it this way. So all I did here was I said polygon. So this you're familiar with, right? Square inherits from polygon, rectangle inherits from polygon. That's all cool. Okay. What I did here is I said polygon implements IComparable. What does that mean? So after I wrote that polygon implements IComparable, okay, let me just make sure that nothing is broken before we move on to this other complicated stuff. Ooh, why does that happen all the time? I don't know why people access the Zoom when I'm logged in. Okay, you guys can still hear me, right? Everything's still working, hopefully. Okay, cool. I've been logged out again. That's so annoying. Okay, there we go. Hopefully it stays signed in now. Cool, you guys can still hear me, so that's good. Sorry about that. It's just because some of the tutors share the like Brighter Future Zoom account. Anyway, so what I said was polygon implements IComparable. What that is going to say is that this polygon is comparable to other objects. You will be able to compare this polygon to other objects. And we're going to go into what that means technically, but you guys know what an interface is. This is just an interface. So when I run this, all it says, the only thing IComparable requires you to do is it says you have to implement a method called compare to. You have to implement a method called compare to, just like we had a method called attack in our interface. So in our interface, we had like an interface called I something, and we had void attack inside our interface. This is exactly the same, okay? This is just, the interface is called IComparable, and all it has is a method. It says int compare to objects obj. That's what the IComparable interface is. It's that simple. It's just that C# has that built in. Okay, they defined that for us. But that's basically all this interface does. Okay, it has that method there. So that's what you must think about. That's all the interface is. It's as if you have this little thing there requiring you to implement this compare to method that returns an integer. Okay, so when I say polygon implements IComparable, all it means is I have to define this method. I have to say public int compare to object obj. Okay, so this returns an integer. Okay, it returns an integer. And what this method must do is I must be able to give it an object. So obviously compare to, it's inside an object already, right? Like our katana had attack. So when I said katana.attack, I just gave it a target, and then the katana would attack the target. And when we had the shuriken, I said shuriken.attack, and I give it a target, and the shuriken attacks the target. This is the same. This compare to method is inside a particular polygon, and when I say the name of that polygon dot compare to, I just give it another object, and it will compare our polygon to that object. Okay? And it does this inside the compare to method. The compare to method. Now, before we get into the technicalities of this, what this must do is define whether this object is this object greater by some definition, okay, greater, so I'm going to put greater in quotes, than obj, okay, obj is the object that's being passed in as a parameter. That's all this compare to method is defining. Is this object as in this, like this instance of the object, you know, this keyword, the object we're inside, the polygon we are inside, is this object greater than the object that's being passed in, okay, object obj, like that object, if you like. Okay, when we're defining greater than, we're defining an order, right? We're defining an order of things. So what I want you to ask you guys is when I'm comparing two things, okay, when I'm comparing two things and I'm trying to find out how they are ordered, like is this one before or after or whatever, how many options are there, guys? How many options are there? When I'm comparing two things, I'm trying to find their order. How many possibilities are there for their ordering? I'm comparing this to that. How many possible orderings are there? Okay, Yusuf, you suggest 2. Okay, let's elaborate on this a little bit more. Clark suggests 3. Okay, Clark suggests 3. Interesting. Okay, so let's elaborate on this a bit more, okay? I'm comparing this to that. So this is like my left hand. Let me just make sure that everything's in the camera because I'm going to explain this visually, okay? This to that, okay? The three possible options are that this comes before that, okay? So that's maybe one ordering. The other option is that this comes after that, right? So like that ordering. The other option is that this and that are equal, okay? This and that are equal. So you can see we've got three possibilities here, right? This is before that, this is after that, or this is equal to that. So in the case of our polygons here, the areas could be, this area could be smaller than that area, it could be larger than that area, or the areas could be equal. Those are our three possible orderings. And compare to will allow us to define all three of those possible orderings in a very like elegant way, okay? Well, somewhat elegant way. I'm not going to say very. I'm not making judgments on its elegance. But so what we'll do is we're just going to use if statements to define this, okay? Now, there's another thing I want to show you guys. You guys know already how to say like if x is less than y, for example. Like if x is less than y, you guys know how to do that. When they do this in practice, like in the book or in tests and stuff, they'll occasionally compare things in a fairly weird way. So what I'm going to do now is I'm just going to say that compare to return 0 so that we don't get any errors. And what I'm going to do is just explain how they compare things. It's quite a nice mathematical idea, I think, if you haven't seen it before. But it's also quite simple, okay? How they compare things. So let's just do this with integers first, okay? We'll be working with areas, which are also just integers, really. But but let's see it with just simple integer variables first. We're going to compare these integer variables. How we might compare them. Let's say I want to find out, is x less than y? We might say, if x is less than y, console.write, x is less than y. Okay, fairly simple example. Okay, that's fairly simple. And you can see when you run this, hopefully you guys are pretty comfortable with how that works, okay? So x is less than y. So if x is less than y is true, and so this prints out x is less than y. Okay, and we could examine other options as well by simply adding more if statements, right? We could just add more if statements. I could say like else if. So I'll say else if x is if x is less than y, so if y is less than x, so x is greater than y, we've said x is less than y. I could define the second one. We can say if x is greater than y, and I can just say console.write x is greater than y. Okay. And the last option would be like else they're equal, right? Console.write they are equal. So those are our sort of three options, okay? Technically there's another option that if we passed in a string where they're not even comparable. So technically that is an option, but we don't care about that, okay? We don't care about that for now, okay? So you can see this says x is less than y. If I make them equal, so int x equals 7 and y equals 7, then it prints out they are equal. If I make it so that y is greater, that y is less, then it's going to print out x is greater than y. Okay, so we can see we've got our three options here, and we've defined it quite simply with an if statement. Okay, they don't usually do it this way. Okay, the reason they don't do it this way, it's super silly actually. Because we're accessing both variables, okay, a lot, which is technically inefficient. It's totally silly. So you don't even have to know that explanation. The point is sometimes they'll do this in a slightly different way, okay? And all they'll do is they'll say int diff. Okay, diff stands for difference, okay? For like difference. Okay, so like the difference between the two numbers. And they'll say int diff equals x minus y. Int diff equals x minus y. Okay. And then essentially you can replace all of these comparisons, okay? So for example, in this case, saying X is greater than Y. So let me ask you guys. So you guys tell me, what do I know about difference if X is greater than Y? So I defined int diff as X minus Y. What do I know about difference if X is greater than Y? What do we know about difference if X is greater than Y? Oh my gosh, again, why are they constantly? So Clark says it's positive, and that's exactly correct. If difference is positive when it's defined as X minus Y, that must mean that X was greater than Y. So instead of saying is if X greater than Y, I can instead say, is difference greater than 0? And instead of saying, is X less than Y, I can ask, is difference less than 0? Okay. And if difference was equal to 0, that means they're equal, right? If difference is equal to 0, that means they're equal. Okay. So I just wanted to show you this because sometimes they compare two numbers in this way rather than comparing them directly. The reason they do it, like the stated reason, is because you only have to access one variable repeatedly. Okay, but it's kind of silly anyway. It's like just so yeah, that's what's happening there. So yeah, I just wanted to explain that to you guys. And now we can go on and define compare to for like the last sort of 15 minutes, and then we'll be done, in fact, for today. Okay. Oh, one more other thing. Okay, so you can see that the compare to method returns an integer. So we say public int compare to object obj. Okay, public int compare to object obj. So what this is saying is that compare to is, it returns an integer. So the result isn't like true or false. It's not a string that says one is less or greater or equal. It's an integer. So how does that like translate? How do we interpret what compare to returns? And the answer is actually, it's not too complicated, okay? So there are three possibilities we want to define. And how they're defined is quite simple. So what we say is, if this is equal to that, okay? So if they're equal, so we're comparing our two rectangles again, and we've got our three options, okay? If the areas are equal, we return 0. Okay? Then we'll return 0, console.write 0. Oh, sorry, the equal case is this last one. So we're gonna say, if they are equal, we're gonna return 0. Okay? And by the way, guys, you can see this on top of the, on top of page 57, there's like some bullet points there if you want to make some extra notes. Okay. The other thing is, if that is greater, okay, if that is greater than this, so if this one comes before this one in the order, okay, if that is greater than this, then we return a negative value. So essentially, like we're this, okay, so we say rect dot compare to another polygon or another rect, another square, whatever. If that is greater than us, then we say negative. Okay, so in our case here, we're this. Okay, we're this. Okay, so if difference is less than 0, that means the y is greater than us. So we return a negative number. Usually, instead of just returning a negative number, we return -1. It'll work with any negative number, but we usually return -1, okay, because it's just easier. And in the last case, where we're greater than that, so this is greater than that, we would say return 1. Okay. And that's how we define our three cases. Rather than saying like x is greater than y, we just say 1. Rather than saying x is less than y, we just say -1. And rather than saying x equals 0, or x equals y, x equals y, rather than saying that, we just say 0. Okay, so that's it. That's all compare to is going to be defining. The only difference is that we're going to use the object values. Okay, we're going to use this dot get area. Okay, And you can see, so dot get area, so the get area method returns an integer. So if we compare the dot get area, we will literally just be comparing, area integers, okay? We're just gonna be comparing integers. Okay, length times width. All right, so let's do that. Okay, yeah, let's go for it. So all I'm gonna do, we've got this exact example here, okay? We've got this exact example here. That is exactly what we need in compare to. What I'm gonna do is I'm just gonna say int diff equals, okay, this dot get area minus obj dot get area. Okay. Notice it didn't autocomplete, right? When I said obj dot, it didn't autocomplete get area. You see, get area is not an object here because it doesn't know that object is a polygon, right? You see, I said object obj. It doesn't know that object is a polygon. What I'm going to do is I'm going to tell it that I want to view objects as a polygon. And how we do that, we call this casting. How do we cast from one type to another? You remember the word is, okay? Wherever the word is can be used, you can use the word as. So I'll show you, and hopefully it'll make sense. So I'm going to say polygon poly equals obj as polygon. Okay. And all that's telling C# is when I use the word poly, or I want to view obj, so this obj, the parameter that comes into the method, I want to view object as if it's a polygon. Okay? So now when I say poly dot, it'll autocomplete and say get area. Okay? You don't have to do this because C# will understand what you mean, but it's just more. So I also just wanted to show you, when you're casting from one type to another, you use the word as, okay? Always use the word as, because it doesn't give any errors, okay? So use the word as when casting from one type to another. Okay? That's just the rule I wanted to show you guys there. We could just make sure that we always pass in rectangles and squares, and we wouldn't have to worry, but I just want to show you that this is possible, okay? You can cast, like turn something. So you see obj is of type object, okay? It's of type object. But I want to view obj as a polygon and save it in a variable called poly. That's of type polygon, okay? And we use the word as for that casting, okay? And now it's simple. So I've said int diff equals this dot get area minus poly dot get area. I can literally copy paste this if else statements that we have here, these if else statements that we have here. I'm just going to remove all of this just to neaten things up a little bit. And I'm literally just going to paste those if else statements into here. Instead of saying console.write -1, I'm going to say return, and I'll say return 1 over here, and I'm going to say return 0 over here. Okay, so if they're equal, so if equals equals, then 0 must be returned, -1 if that is greater than this, and 1 if this is greater than that. So just that relationship we explained earlier with x and y. We're now just doing it with this dot get area and poly dot get area. So it's identical, okay? So hopefully everyone's comfortable with that idea. I can remove this last return 0 as well now, because we've defined compare to. And what does this allow us to do? It's very simple, okay? It's actually similar to what our attack was doing. I can now say square dot compare to rect. Square dot compare to rect. I'm going to print it out so that we can see what the result is. So I'm going to say console.write square dot compare to rect. And I'm going to spell console correctly. So console.write square dot compare to rect. And you can see it prints out -1. Why did it print out -1? Well, square is this. So 10 times 10 is 100. Rect is that. It's the one that's coming in. It's obj. And that's 10 times 20, which is 200. So this was less than that. So it prints it out minus 1. You guys can tell me, what happens if I say rect dot compare to rect? Let's look at a special case. What if I compare rect dot compare to rect? What do we expect to be printed out here, guys? 0, exactly, because their areas are equal. Rect's area is exactly the same as itself. So yeah, Clark and Chris, you said 0, and that's correct. So we're comparing it to itself. So that's a little special case for you guys there. What if I say rect dot compare to square? Rect dot compare to square. 1, exactly, because this is greater than that. Okay, this is greater than that. So when I run this, see it prints out 1. So literally all it does is allow us to compare these two objects to each other, okay, by some metric. I could also have used the length, right? Like if I, instead of saying this dot get area, I just said this dot length is minus poly dot length. I could compare the length of this to the area of that, or the length of this to the width of that, or the area of this to the width of that. I can do any comparison I like, and compare to will allow me to do it, right? And you can imagine how useful this is, like if you're creating a game or something, right? Because you can compare the level of this enemy to the damage output of that enemy, the hit points of this enemy to the damage of that enemy, or you can imagine when comparing, doing anything. It's a very useful idea to be able to compare these two different objects along any line you want, okay? In this case, we compared this area to that area, but there was no reason why we had to. We could define this relationship however we want. We could do it alphabetically. We could do it that if that's a square and this is a rectangle, then this is greater. We could compare them however we liked. We could compare these two objects, their levels, their sizes, their hit points, their damage, their areas, their lengths, their widths, their heights, whatever. Okay, their weights. If we were still working with persons, we could compare blue to brunette and have like some kind of ordering system that orders people by hair color. We could do a ton of different things. Okay, any comparison you liked. That's what compare to allows us to do. All right. Cool. So yeah, quite a simple idea. I think let's go through one more example. If I change rect's width to 1 and I say rect dot compare to square, what will this print out? What would this print out now, guys? So we're comparing their areas. Squares now. Square has a length and width of 10. Rect has a length of 10, width of 1. And I'm saying rect dot compare to square. What would that give me? Have to think about it a little bit, I guess. Okay, I assume you guys have the idea now. So maybe I'll run it and then we can see if your assumptions, even if you're too scared to share them, are correct, okay? So I hit run it, it's working it out, and you see it returns -1. Why did it return -1? Because rect has an area of 10 because 10 times 1, and square has an area of 100, 10 times 10. So when I say rect dot compare to square, rect this is less than that, so it's -1. Okay. And that is actually it for chapter 4. Compare to is the last thing we had to cover. And yeah, that's it. Or sorry, chapter 2. What am I saying? Chapter 4. Yeah, that's it for section 2, for chapter 2. And yeah, next week we'll do the knowledge assessments and the little like test thing. And yeah, that's it, guys. Nicely done. I think chapter 2 is the hardest in the course, by the way. I think chapter 2 is the most difficult in the course. I really, really like chapter 3, the next chapter that we start. I think it's maybe the second most fun. Chapter 4 is the most fun, I think. But yeah, that's it for today, guys. I'm surprised we finished a little bit early because I think interfaces were quite difficult. I want to remind you guys, I am going to be sharing our interface example on the WhatsApp group. And I'll also link to all of the code we did today inside the YouTube description, the description of the YouTube video. And yeah, so you'll have access to all of this code when, if you're ever revising or anything like that, okay? But yeah, that is it for today, guys. Thank you very much for coming. Enjoy the rest of your weekends. And yeah, we'll call it there.